Have you ever wanted to compare two variables to see how they relate to one another? Well, today is your lucky day. Paul Hendrickson here to teach you all about linear probabilistic modeling. This model is used to find the probability of various outcomes using linear regression. For example, one would use this model in a scenario such as what is the chance of a certain error y occurring in the production of light bulbs given previous data. Now, what is linear regression? Well, linear regression can be visualized using the equation shown in the middle of the screen. Y equals b sub naught plus b1 times x1 and so on. In this model, the point estimate of y is not what is of interest, but instead the mathematical description of probabilities of the various outcomes is. This model can be used in many engineering applications, one of which being how often your product, such as a phone, fails given the temperature outside. The equation used in the linear regression model is very similar to the equation we learned way back in algebra. The equation we use to find slopes in algebra, y equals mx plus b, is very similar to y equals b sub naught plus b1 times x1. If you notice, m is the slope and b is the y-intercept. We see that beta sub naught acts as the y-intercept, beta 1 acts as the slope, and the independent variable, which is the assigned fixed variable given to the experiment from the experimenter, is x. The opposite of that is the dependent variable, which will be y. It's a random variable. There's also an extra term called the random error term. What this term allows is for y equals beta sub naught plus beta 1 times x. It gives it a true regression line. And thanks to this term, the data will always lie somewhere inside this true regression line, whether it be on top of the regression line or below the regression line. For example, we look at how often phones fail given the temperature when it is left laying outside. Our independent variable x is the temperature, and the dependent y variable is the amount of phone failures. This model shows us that the hotter it is outside, the more phone failures there will be. This is a good example of linear probabilistic modeling, because we can now predict at what temperatures the phones will fail and engineer a solution for these phones, so hopefully the product will be better. I hope this sells you on linear probabilistic modeling.